Hello everyone, my name is Zhen Junyan, come from Nanjing Normal University. Today, my topic is Unified Expressing Frame of Geodetic Stations based on Conformal Geometric Algebra. This is my information. Hope to communicate with you. I will introduce my work from 5 aspects. First of all, starting from the research background and significance. Geodetic stations calculated by four special geodetic technologies GNSS, VLBI, and so on. Different technologies have different reference systems. As we all know, GNSS includes WGS 88, CGCS 2000, GTIF, and so on. All in all, their special references are different. The reference frame can be divided into spherical frame, orthogonal frame, and plane frame. Differences in the frame make it difficult to the integrated application of different geodetic stations. Comprehensive applications such as smart cities require data from different sources. Due to advance in observation methods and computing capabilities, practical demands put forward new requirements on GIS. From the above introduction, we learn that if we construct a unified express frame for multi-source data, it will be of greater significance for practical applications. For example, based on the unified expressing frame of geodetic stations, we can construct high-precision ITF. Meanwhile, unified expressing frame of geodetic stations can be used to simulate the motion trend of the Earth's plate. Then, let's introduce the research status about the topic. The 7-parameter model is commonly used conversion method, as shown in Formula 1. The conversion method is based on the matrix operations. The translation matrix is used to epoch conversion. The frames conversion involves the translation, rotation, and scaling matrix. During the conversion, the translation, rotation, scaling is associated with the translation operator, rotation operator, and scaling operator in GI. Translation operator, rotation operator have been applied in many research fields. Many scholars have designed and used different motion operators such as Li, Zhou, and Fan. The research about the motion operator provides a favorable idea for the unified expression of geodetic stations. Different special references have greatly hindered the integrated applications of different geodetic stations. The existing problem is cumbersome in form, complex in the calculation process, in the conversion process. The formula expressing from epoch 1 and ITF1 to epoch 2 and ITF2 is as shown in the following, which is lengthy and complicated. In order to solve the problem, we introduce CGI as a unified expressing frame of geodetic station. The research method is introduced. The introduce includes 4 parts: construct motion operator, process decomposition, construct unified reference frame, practical applications. Firstly, we should construct rotation operator, translation operator, and a scaling operator based on the product. The rotating operator is shown in Formula 4. The translating operator is shown in Formula 5. The scaling operator is shown in Formula 6. Secondly, we decompose the process of the frame conversion and construct a mapping relationship between the operators and the conversion process. The reference frame conversion includes epoch conversion and frame conversion. As for epoch conversion, it can be complicated by translation because the shape of the Earth is in the process of slowly changing. The change of the position of the geodetic stations can be regarded as a uniform motion over time. Frame conversion is the position change of the ITF frame in space, involving rotation and translation of the coordinate axis and scaling between different scales. Thirdly, construct the operator of frame conversion according to decomposition process. The operator of frame conversion involves 3 rotating operators, 1 scaling operator, and 2 translating operators. As for the rotating operators, taking x-axis, y-axis, and z-axis as rotating axes respectively, rotating operator Rx, Ry, Rz can be constructed. As for the scaling operator, based on the scaling parameter, scaling operator can be constructed. As for 2 translating operators, for epoch conversion, translating operator can be constructed based on the translating vector. For frame conversion, based on moving vector to construct translating vector and translating operator can be constructed. Based on the above operator, the formal unified expression of conversion can be realized. The specific expression of the conversion between different epochs and different reference frames is as shown in Formula 8. Under the unified framework, using the singular value decomposition method, the plate motion is analyzed and simulated. Given the initial vector field y and the end vector field x, based on the versor product, the transformation formula is constructed where R is the motion operator in CGI. Through the following formula, we can calculate the motion operator. If we get the motion operator, we can get the motion trend of the Earth's planet. For the above methods, we have done experiments to verify the feasibility, effectiveness, and simplicity of the conversion method. As for ITF conversion, this experiment collected different types of geodetic stations, a total of 288 geodetic stations. Due to the larger amount of data, this paper used the 4 GNSS stations as the experimental point. The coordinates of the 4 stations are shown in Table 1. The epoch conversion of the ITF frame is determined by specific station, as is shown in Table 3. The translating operator is as shown in the formula. As for the transfer frame conversion on the unified epoch, the conversion parameters are shown in Table 2. According to the conversion parameters, we can calculate the parameters of the operator. The specific expression of the operator is as shown in Table 4. Specific expression of a reference frame conversion are shown in formula. After the conversion, according to the formula, the accuracy can be calculated as is shown in Table 5. The accuracy of the centimeter level will be satisfactory. It can be seen from Table 5 that the accuracy of the conversion is at the millimeter level, which can meet the accuracy requirements. Based on the unified expressing method and above conversion method, the data of all stations are transformed into the unified frame. After conversion, we can obtain the velocity field values of the station based on the coordinate values. Then, the plate motion can be simulated according to the velocity field. It can be seen from the figure that the speed of the station on the boundary is relatively large, while the speed of the station inside the plate is relatively small. From the above experiment, we can draw conclusions. The ITF frame conversion method based on the unified expressing frame is feasible and effective. This method overcomes the tediousness and complexity of the traditional method. Meanwhile, the plate motion can be simulated under the unified expressing frame. There are many things that can be done in the future. In the future study, the accuracy computational cost between matrices and operators is a risk point in the future. The redundancy of data storage is another research point in the future. That's all. Thank you for your attention.